How are you, my friends? In this video, I'm presenting 7 old exams questions related to determinants and their properties. These are coming from lectures 35 and 36 of the pre-calculus course. Question number 1, find all the values of x in the equations A and B. So easy. The first one, determinant 2 by 2 is equal to 0, so we can just solve it. We evaluate the determinant, 2 by 2 determinant, to find the value of x. So we multiply 2x minus 1 times the x minus 3 times 5, according to the formula, is equal to 0. Just expand the equation, 2x squared minus x minus 15 is equal to 0. We can factor this, I think, yeah, 2x plus 5x minus 3. Check it here. This is minus 6 and 5, that's minus 15. So x will be minus 5 over 2 and 3. Two values for the x. Now for other rules and formulas, you can check the lecture 35 and 36, please. Second one, same idea. The determinant is equal minus 13. Let's evaluate the 2 by 2 determinant. Multiply 2x minus 1 times the x minus the other diagonal, 3 times 5 is equal minus 13. Rearrange it. You get here 2x squared minus the x, and here we have minus 15. You bring minus 13 on the other side, becomes minus 2 only. So a is 2, b is minus 1, c is minus 2. We cannot factor it. That's why I put this question here. Cannot factor, so we use quadratic formula. X will be minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Put the numbers there. These are the values of the x. So the solution are the values of the x. Given the matrix T, 4 minus 3, 3, 2, 1 minus 4, 6 minus 2 minus 4. Find the value of capital M13 plus capital C32. This is a minor, this is a cofactor. I think you have seen that in the lecture. So 3 is located where? In the first row, third column. So this is the 1 and 3. First row, third column. So M13 is the minor of the 3. So minor of the 3, we just delete. First row, third column, we are left with 2, 6, 1 minus 2. Just the determinant of 2 by 2. So that would be minus, here minus 4, and then minus 1 times 6 will be minus 10. That's the minor here, M13. Now to find the cofactor, capital C32, you have to use the formula here. See, there's a formula for the cofactor, you know that. Minus 1 to the power I plus j times the minor of ij. So third row, this is the third row here, second column. So this is the cofactor of this minus 2 there. So minus 1 to the power 3 plus 2, which is minus 1 to the power 5. Delete row 3, column 2. We are left with 4, 2, 3 minus 4. When you multiply, you get minus 16 and then minus 6. So minus 22, and there is a minus 1 to the power 5 is minus 1. So we have the minor is minus 10, M13 plus 22, the answer will be 12. Now, question number 3 says, solve the equation. We have here determinant of 3 by 3, 0, 1x, 1x minus 1, 1, 1, 1, 3. The determinant is equal to minus 3. So first we have to look on the left side and find the determinant. Let's put it in triangular form to make it easy. See here, I have 0. So it's better, a good idea, that I interchange row 1, which is 0, 1x, I put it here in row 2, and row 2, 1x minus 1, 1, I put it up here. But I have to multiply that by minus 1, interchanging 2 rows. So I put minus 1 outside. Now, this one is already 0. I have to change this number here to 0. So we can multiply row 1 here, 1x minus 1, 1 by minus 1, and then I will add to 0. Remember, multiply by minus 1, this is 0. Multiply by minus 1 becomes minus x plus 1. And there is a 1 here, becomes 2 minus x. Multiply by minus 1, add to 3, you get 2 there. Now, what can I do? I multiply here by x, this is 1 here, multiply by x minus 2, and then I will add to this to get 0 there. So I multiply by x minus 2, I get 0 there, multiply x by minus 2 by x, becomes x squared minus 2x, and then I will add to 2. So now easy to find this determinant, multiply the elements on the main diagonal, 1, 1, x squared minus 2x plus 2, multiply all these three, times the minus 1, don't forget that. So now, it's given the determinant will be minus 3, so I put minus 1 there, the determinant from the inside, which is 1 times x squared minus 2x plus 2 equals to minus 3. Then I simplify the equation here. I get x squared minus 2x plus 2 is equal to 3. It takes 3 on the other side. It will be x squared minus 2x minus 1. So A is 1, B is minus 2, C is minus 1. We cannot factor. Use the quadratic formula. And then the values of the x will be 1 plus square root of 2 or 1 minus square root of 2. Now, this is a little tricky question. A is, we have here 3 rows, 3 by 2, and B has 2 rows, 2 by 3. Now find the value of the determinant of BA. We know there is a rule, determinant of BA is equal determinant of A times determinant of B. But these A and B should be square matrices. These are not square. So nice idea we can do that is to multiply here. They must match, remember here. So this is 2 rows, this is BA. Now B I put here, and this is A, 3 by 2. So these numbers, they match. And the product will be 2 by 2, which is a square. So you have to check the dimension, multiply, then the answer will be 2 by 2. Then after that, you can find the determinant. That's a little tricky question. Just multiply normal. Multiply row by column, row by column. You know how to multiply matrices. I put here all the details for you. So you multiply row by the column here. 2 times 2, 1 times minus 1, minus 2 times 3. So you get minus 3, minus 9, 2 minus 4. Let's find the determinant of BA. So determinant of minus 3, minus 9, 2 minus 4, we multiply here. You get 12. And then minus, this one here will be minus 18. So 12 minus minus 18 will be 30. This is a good idea because it contains determinants and inverses together. Given matrix A, 3x2 minus 1, the determinant of the inverse minus 1 over 15. Find the sum of all elements, or the entries, or the members, or the numbers of A inverse. So this is A, this is the determinant of the inverse, and we need the elements of A inverse. We need to add them. How do we start? This is A, and this is the determinant of the inverse. We know the determinant of the inverse from theorem 18, lecture number 36, 1 over determinant of A. And determinant of A inverse minus 1 over 15. So I can put 1 over minus 15 to match with this formula. See this formula, determinant of the inverse, 1 over determinant of A. If you compare this and this equation, then you can conclude the determinant of the A is minus 15. Now you can go back to the matrix A, 2 by 2, find the determinant, vertical bars, remember. So 3 times minus 1 minus 3 minus 2x is equal minus 15. X will be 6. So now you can write A. Look at A now, 3, 6, 2 minus 1. So neat. 3, 6, 2 minus 1. So we need the inverse of the A, and then we add the entries. So there is a formula for the inverse, 1 over AD minus BC, you know that formula. And then you interchange here these numbers, minus 1 and 3, multiply with minus 1 there, and multiply by the scalar, minus 1 over 15, you get, this is the inverse. Now you add 1 over 15, 6 over 15, 2 over 15 minus 3 over 15. The answer is 2 over 5. Now, question number 6 says, if X and Y are 4 by 4 matrices such that the inverse of X exists, the determinant of the X is 3 and the determinant of Y is 2. Let's find the value of determinant of XY minus 30 determinant of X inverse plus the determinant of 2Y. So first we multiply the Y by 2. Remember, Y is 4 by 4. So there are 4 rows, 4 columns. We multiply that by 2, then we find the determinant. So the first one, X times Y, the determinant of XY will be determinant of X times determinant of Y, 3 times 2, minus 30. Determinant of X inverse will be 1 over determinant of the X, plus the determinant of 2Y will be 2 to the power 4, because we have 4 rows. Each one is multiplied by 2, times the determinant of the Y, which is 2 itself from here, the given. So that will be 6. 30 over 3 will be 10. 2 to the power 4, 16 times 2 is 32. And this will be 28. Question number 7 is really a nice question. Find the sum of the following if possible. Part A, we have determinant of 2 by 2 plus determinant of 3 by 3 plus determinant of 4 by 4. In B part, we have matrix 2 by 2 plus matrix 3 by 3 plus matrix 4 by 4. Big difference between A and B. A, the determinant is a number. So this one is 10. You can figure out, multiply this minus that. That's 2 by 2. 3 by 3, see example 5 in the lecture. And then you can find here the determinant will be minus 6. Also, you can see here example 8D in the lecture 36. And complete steps on the next slide for this determinant minus 120. So when you add 10 minus 6 minus 120, it will be minus 16, the answer. Now this is the, you have to put the given here in triangular form. So we have to use Rose transformation 5 times. We can use apply theorem number 7. So to use this one to change this one to 0, this one to 0, this is 2 times. Then use this 2 to change this one to 0, this one to 0. So this is another 2, so that's 4. And then use the 6 multiplied by minus 2 to change the 12 to 0. You have to change this number here. So this is 5 times. And then you have zeros under the main diagonal. This is triangular form. So multiply 1 times 2 times 6 times minus 10 will be minus 120. Now B part is the sum is not possible, or we can say the sum is undefined. Why? 2 by 2 matrix. We cannot add to 3 by 3 matrix. We cannot add to 4 by 4. Because to add matrices, we have to have the same dimension. These are the answers of the 7 questions. For other examples, please, you can see the video on pre-calculus course, lectures 35 and 36, determinants and their properties. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much for listening.